Hello, everybody, and welcome to the Point, webinar series by Mimosa. Today's topic we're covering is why wireless is the future of fixed access. My name is Lee Peterson. I am the Director of Technical Marketing here at Mimosa. What we're here to talk about today is why Mimosa, our strong belief is that wireless really is the future of where we're going with internet and where connectivity is going to be into the next 10 or 20 years and beyond. Really what we're sort of calling the fixed internet renaissance. And if we look at where the market has been and where it's going, that's why we believe that it's a really great period of time to be in the wireless industry and to be deploying wireless equipment to be able to deliver speeds out to the customers that customers need. So if we look at the history of where the market's come from, back in the 2000s, WiMAX came along with a lot of promise about what it was going to be able to deliver. And then it sort of evolved into Motorola, which then became Cambium, and Ubiquity coming in as a very price disruptive solution in the rural space. So there were a lot of solutions, Mimosa included, available now to service these rural markets where there is an under availability of other options for getting internet at a decent price point and at a decent level of performance. Within the suburban markets, ADSL evolved into DSL about the mid-2000s, and a previous company I was at, 2Wire, where our founding team also comes from, we really saw that the inflection point of DSL as the access technology of choice, where it started to go into net decline from that point as VDSL came out into where we are today. And so that's evolved into where there's others out there doing things like Verizon doing Fios, AT&T with their UVerse solution, and of course, which gets a lot of press, is Google Fiber as part of the Alphabet series of companies. We'll talk about that a little bit more in a moment. Of course, in some markets, in the US particularly, in parallel to that, we have the cable cos out there doing DOCSIS and the evolution of that into DOCSIS 3.1, and the sort of speeds they can deliver there with that platform and that technology is impressive. But of course, the footprint's somewhat limited, and they've also had issues with how they transition in terms of the efficiency of the use of the cable, the infrastructure that's there, in terms of what they do with TV services, which are very inefficient in terms of how they use the available spectrum there. The evolution of that is going to require a big investment in infrastructure for them to get it beyond the speeds of where we're achieving today with DOCSIS 3.1, with channel bonding and some other technologies like that. Then, of course, there's the urban market. So ADSL, fiber, copper, all those technologies at play in the urban market. We've been very interested to see where the perception of wireless as a solution for developing and delivering internet services in a built-up urban environment. We talk about WebPass, which are a company local here in San Francisco that actually many of our employees that live up in the city do use and speak very highly of, and the recent moves with Google in terms of their ownership of that and what that means for the market. And then, of course, the regulatory environment obviously plays a big part here as well. And so if we look objectively at the election results in terms of the makeup of the members of the FCC currently, Commissioner Pai is being touted as probably the interim commissioner, as a Republican member of that commission. And he has proven and certainly publicly stated that he's very friendly to the WISPs and very friendly to what we're trying to achieve in terms of using wireless to deliver these services out to these areas that are underserved and underutilized. If we look at some of the things that have happened recently, and some not so recently, for example, a few years ago, the FCC changed the definition of broadband to be a minimum of 25 megabits per second as a service. And that really means that the technology needs to grow up to be able to deliver that over wireless. And we feel like we're really getting there. But that means a lot of the legacy technology is going to have to be swapped out to do that. If we look at the initiatives around the 5G millimeter wave spectrum frontiers approach, which is a very sort of telco-driven approach, taking a lot of spectrum, 11 gigahertz of total spectrum at millimeter wave above 24 gigahertz, and making that available for use for these sort of services too. Whilst we don't necessarily agree with the interpretation of how that's going to be used, it's certainly a good, it's an intention showing a positive intent in terms of making capacity available for delivering services over wireless. And then lastly, looking at the FCC in terms of the Spectrum Access Sharing Database approach in 3.5 gigahertz, that's obviously a good thing in terms of having an ability to take some of this very scarce, very valuable spectrum at those lower frequencies and share it. Make sure that incumbents aren't disadvantaged by the approach that they take to giving access to other people and being able to share that spectrum adequately and in a very fair and equitable way without resorting to large auctions and other very expensive processes like that to allocate that spectrum out to users. So if we look at what's driving a lot of the the need for these high bandwidth services. It's very clear that the cord cutting trend is something that's been a big driver of the behavior in the industry, not just in the US, but worldwide. Specifically in the US, 25% of US homes no longer subscribe to cable or satellite TV services. And there's a few reasons driving that. One is cost, for obvious reasons. The packages, as they get more expensive to acquire that content, the minimum spend on that sort of services increases. But there's obviously also the Netflix effect, the availability of these high definition video services that allow people to get content via different methods over IP. Now, the sort of validation of that as the right approach is if you look at the recent entrance into that space. Of course, Netflix, Amazon, Hulu have been doing this for some time, but with Sling Television and then the recently announced DirecTV Now service, which is now part of AT&T, it shows that even the incumbents are trying to cover themselves to make sure that as this cord-cutting trend continues, that they're positioned to be able to deliver their content in an agnostic sort of way without having to have lock-in to the method of delivery in terms of satellite, cable, and fiber as the delivery mechanism for those. Now, the current environment is predominantly 1080p type streaming. Of course, that will evolve to 4K as 4K televisions get more popular. And then beyond that, that's obviously 8K and other more richer, higher bandwidth type delivery is going to be needed to keep up with this demand that's going to be almost similar to when the inflection point of landlines going away and being supplanted by mobile phones as the primary method of accessing phone services. This is probably getting close to the tipping point of that for video services, which are increasingly looking like they're going to be delivered over IP, not over traditional methods. Then talking about where this evolves into the future, well, there's a whole bunch of applications that we sort of haven't even dreamed up yet. Virtual reality, augmented reality type services, the bandwidth demands of those and the demand for low latency is also going to drive a significant investment in the network to be able to satisfy the end user demand for these type of services. So the sort of position we have is that we've got to break this tendency to think of gigabit always meaning fiber. Because the reality is fiber is great. Fiber is always going to be part of your network deployment, but it's not always going to be economical to push fiber all the way to the end user and to the last mile. The range of estimates we've seen in terms of the cost of doing fiber, those that can do it very cost effectively, maybe $600 to $700 per household. And the bigger guys that are trying to deploy this fiber, it could be as much as $2,500 per household. And if you think about a household that you're selling a basic internet service to, that could be $30, $40, $50, maybe $60 a month of revenue from that customer. And of course, as you calculate out the return on investment on that, it's going to be very hard to recover that initial investment that's made without locking people into contracts and other things like that, which people are very resistant to. There, of course, is an inability to even consider fiber in many developing countries where the right-of-ways, the pole access, the access to underground assets just really doesn't exist in terms of if you even wanted to deploy fiber, if you financially were able to do it, it's unlikely that it would be practical just given the heavy amount of capital works involved in trying to build that infrastructure up to support that kind of deployment. So circling back around to Google and sort of when we look at our approach to when we look at the market, 5 years ago, we went all in on starting this company and looking at doing wireless, and we really do believe that the speeds and the ability to deliver gigabit type services over wireless exist. And it's sort of the world's come to us and the market's come to us in some ways in terms of them catching up with that thinking. Certainly Google pretty much putting any further fiber rollouts on ice as a result of Alphabet and that getting formed as a company and the Google Access Group being folded out, and having to suddenly justify its existence and justify the immense expenditure involved with rolling fiber out has meant that they've paused that and they are looking for more cost-effective ways to do that, which is, as a result, why they purchased WebPass. And I think that's what we're going to see as a model for them rolling out services in new territories, is using wireless to do that, doing fiber to where it makes sense, and then hopping off onto wireless to deliver that last mile type connectivity. Of course, the telco community, the mobile phone service providers as well, look at the desire to deliver fixed type services in addition to the mobile roaming type services they offer. And we really don't see if you look at the access restrictions that are having to start being put on things like, for example, T-Mobile here in the US, yes, you can access unlimited streaming, but they've had to choke that streaming down to a lower bit rate to ensure that those constant style streaming services don't choke the network up. So given the scarcity of spectrum that exists, the cost of investing in infrastructure that's required in that network to support mobile type users, we don't see that as a future solution that's going to be used en masse for providing fixed broadband type services to consumers and to businesses. And that's really where the confusion exists, I think, is that a lot of the efforts and a lot of the discussion around 5G is talking about it as an infill technology and talking about it as something that can be used to offer these fixed broadband services. So we agree with Verizon's assertion here that rolling these things out wirelessly is the most cost-effective way to do it. We don't necessarily agree with the next step in that thinking, which is to just ride on the back of the Ericssons and the Huaweis of the world that are delivering the services that are more optimized for mobile type services. We do believe that there's an alternative needed, and that's really where Mimosa comes in. So before I jump into the details of what we do and how we fit in and play into this market, just a little bit of an update about the company in terms of where we are. So as I mentioned already, started 5 years ago, a privately funded venture-backed company. We're now at the point where we're over 100 employees and fairly globally distributed with a primary office here in Santa Clara, California, a development office in Istanbul, and an office in Taiwan as well. And interspersed with that, we have individual people available in different regions, Hong Kong, Singapore, some in the UK. So we do have a fairly good amount of global coverage now in terms of being able to serve markets and be able to serve our channel to be able to get products to our end users. We're now at the point where we're shipping the full suite of products, which is what I want to give a brief overview of today, across backhaul access and client products in the house. And that's really exciting for us to go from sort of whiteboard ideas of what we thought this future looked like to be able to legitimately deliver service all the way from end to end to an end user and be able to offer the sort of speeds and the services that we believe that people need to grow up and be able to compete with the big guys out there, to compete with the AT&Ts and the Verizons of the world that are not going to be as local as you in terms of where you're regionally located, but are still going to probably try and compete with you. And what that really leads to is this model of what we call the hybrid fiber wireless model. So the idea is that fiber is absolutely part of the play. It needs to be. You need to push fiber as deep into your network as you can. In certain cases, opportunistically, that might mean pushing fiber all the way to the end user if you can get favorable rights to do that or favorable financial situations to do that. But the reality is that if you can push it out to your POPs, if you can push it out to your edge of the network as far as possible, and then use wireless to cover that last mile connection, that's always going to be a much more cost-effective way to go, and it can be done in a way where that does not put you at a disadvantage against fixed service providers using copper and using fiber even to deliver services to end users in those areas. So the market in terms of where it stands, the rural market is a big part of what we do. It's very important to us, just given that there is obviously a lot of altruism associated with when I talk to wireless ISPs anywhere in the world about why they started. A lot of the time it is about I wanted to serve my community because I could see there was no other options available, and I want to be able to do a good thing for them and be able to deliver services that they otherwise wouldn't have. And that'll continue to be a focus for us. We have solutions that do play in the rural market, but where the growth is going to be in these suburban and urban markets. And we want to be able to have a situation where those on the fringe areas of some of those suburban areas can go in and compete using the same technology and the same techniques that are used in rural, but maybe just applying them in a slightly different way. And given the population density there, 80% of US households being located in cities, that means that the potential for growth from doing so and being able to go in and own an area is much greater than trying to do it in a much more sparsely populated rural area. So the components of the solution in terms of what we do, Mimo is such a fundamental multiple input, multiple output, such a fundamental part of what we do that we named the company after it. So the name Mimosa is literally just we wanted to use something with Mimo in it because it is so key to everything we do. TDMA is very important. So being able to use TDMA as a technology to achieve extreme efficiency in terms of as we translate from the PHY rate that's available at the raw physical layer of a wireless connection to what I actually get at the MAC layer in terms of IP throughput. So an enormous amount of our engineering effort goes into these 2 points, which is TDMA and sync, around have very efficient TDMA protocols that can be very good in terms of getting high throughput from the available PHY rate, and then using GPS synchronization on top of that in conjunction with TDMA to make sure that I can reuse spectrum where possible to make the most efficient use of that possible. And then, of course, tying it all together, we want to be able to use the cloud to plan and manage and to make sure that the devices are all configured the right way and behaving the right way as well. So on that Mimo point, and those that have come to these webinars before, this slide does come up a lot, but like I said, it is so fundamental to what we do and what we achieve here, is that as we sort of look at the growing up of Mimo as a technology, we're at a point now where 4x4 solutions are starting to become more standardized, and the evolution of that into multi-user Mimo and then eventually into 8x8 solutions, we've seen a 10x increase probably in the last 10 years in terms of the capacity available. And Mimo is a big reason for that ability to be able to get more spatial streams over a given piece of spectrum is why we're able to achieve the sort of speeds we can today. So as I walk through the end-to-end solution for us, I just thought I'd start at the end user, start at the client, and then work back. And one of the reasons to do that is that the client solution doesn't vary greatly between the different segments that we target. So in this case here, we're showing a C5, which is our client device. That, for a longer range rural solution, will be able to be substituted with a C5C, which is our connectorized client device that'll be coming out early next year. So that gives you the flexibility to choose whichever is best for the type of distance you're trying to achieve. And the idea is to do this in a very low, a very cost-effective way. So we always want to try and make those devices as best value as we can, but also just a minimal visual impact, because this is something that's going to be up on your chimney or up on a pole or maybe on the wall of your house, and something you're going to look at every day. So we don't want something ugly and ungainly. We want to make sure that it's as minimally visually impactful as possible. We also supply and recommend the use of our network interface device. So before I get to that, the mounting solution, obviously we have two options on the mounting available that can be purchased as an option with our unit, or you can use your own mounting solutions if you have your own. That's part of the reason we have the flexibility to choose and pick in the parts of the solution that are most relevant to you. With the gigabit network interface device, we recommend that as a good way to protect yourself as you go out and deploy this style of services. The last thing we ever want to see happen is have an event of some sort, an ESD event, have that spark some sort of fire hazard inside the house because you don't have termination between the outside wiring and the inside wiring. So very cheap device, $10. We do recommend the installation of that. As an added bonus, what that also gives you then is a service interface. So it means that if I need to come around to that premise and do some maintenance, maybe I need to realign a dish, maybe I need to change the CPE out, even with the customer not being there, I can open that network interface device and using a battery power the C5 and connect into it and do whatever configuration changes I need to locally without disturbing any of the setup inside the house or any of the in-house wiring or any of the in-house Wi-Fi. And then inside the house, we have two options around what to deploy there. One is a standard PoE, and the other is our G2 device, which I'll talk about a little bit more in a moment in terms of a managed Wi-Fi access device inside the house that can be part of your service provider offering. So when we look at the options, one of the reasons we took this approach is that we want people to be able to pick and choose what is most suitable for them. So maybe they have their own mounting solution, but we thought we'll try and build the best J-mount and the best what we call our flexi mount that we can, so that is something that can be ordered en masse as the same time as you're doing your CPE deployments. The NIT as a protection device is a separate thing that, again, can be ordered in larger quantities to have those as part of your standardized install. And I should point out it's not specific to us as well. So it's something that we have seen people say that they want to use that with other vendor deployments, and we're absolutely happy to do that. And by having this as being a very cheap device, it does mean that it can become part of your toolkit and part of your standard practices. And then in terms of in the house, one of the reasons we don't supply a PoE with a client device is that we want people to be able to choose the option they want to best support what they're trying to do. So we have a standard PoE for $10. That's the US dollar MSRP. And then for $49.99, we have the G2 device. Now, the idea of the G2 is a few things. Like, one is that we want to be able to have a very neat solution for powering the outside device. So doing that in a wall mount type fashion like that means that it's not a clutter of cables. But the other is really to turn this into a managed endpoint within the customer's home as well. So by doing so, it means that I can actually start to support the customer's in-home Wi-Fi network as well. So if I have a customer call up and complain about a specific device, I can, with the cloud tools we have available, look at that specific device, look at its connection history, and be able to do troubleshooting that way to understand, is there a specific device in the house that's downloading more? Is that a device that's on the fringe areas in terms of range? So it is something that just allows you to, instead of shooting blindly trying to troubleshoot these issues, because even if it's not an issue specifically with something to do with your service, the service provider is typically the person the customer will call for help with any of those issues, even if it's something that, they're setting up my wireless printer from Best Buy. That still ends up becoming the service provider's problem to try and help people through those kind of things. So that's an important piece, we believe, in terms of just being efficient and making sure you create a great customer experience for that customer versus relying on them using other third-party devices that you can't support as well. Now, the other piece of this is to create as much coverage as possible within the home. So with the G2, it can be used as a wireless extender over Ethernet, so that's what we call an extender, or we can wirelessly repeat as well. So we have that ability to create a good amount of coverage through the home so that we can seamlessly roam between each of those devices, so no matter where the customer is in the house, they're not getting a bad experience. Now, the next piece of the subscriber experience is not so much about the subscriber experience, but it's about your installer experience. So we really want to create an environment where you can go out and hire installers that maybe have done satellite installs before. Maybe they're not so great at computer configuration or getting IP settings configured in a PC, but they understand how to follow a procedure and understand how to follow best practices for things you do. And that's really what the intention is with the Mimosa install app, is to simplify a lot of the tasks that go into doing every install. So being able to, we have a process called the unlock process where we activate the devices for first use. So having an automated way to use the QR code on the device within this app, which will work across both iOS and Android, to be able to perform that step and to also then use the GPS coordinates in the phone to mark the location of where that device has been installed. We're also going to allow this to cache firmware. So this app itself will have the latest version of firmware in it. And even if you're offline, you'll be able to connect to the device and push the latest firmware to it automatically. Configuration is obviously a big part of that. And one of the things we want to do there is template that out. For the most part, maybe 95% of what you configure into a device is the same, with a few unique little characteristics or identifiers related to the end user. So being able to make the standard things be part of your standard profile and be able to do it where you can just customize the little things you need to. Aiming and connecting, so making sure that the device is oriented towards the access point and getting the best signal strength possible, and being able to save those configurations so you can use them in the future. And so that'll be available next quarter. The app itself is ready. Where we're spending our energy now is just making sure that the APIs that we call on the device, just trying to make that as efficient, as quick as possible. The other thing to mention is, of course, the method of connectivity between the app and the device does not have to be the G2, but we've optimized this around assuming that there's a G2 in place, because this device will connect to the Wi-Fi in the G2, which will then in turn allow you to connect to the client device in the customer's premise. So on Backhaul, I've only really included one slide here. So we'll cover this and then we'll get into access. So I just wanted to sort of stress that in terms of what we have available and what's the best tool for each job, starting at the B5 Lite, which is our 2x2 solution for connections up to 750 megabit per second in aggregate throughput. Now that device is identical from a hardware perspective to the C5. It's just a different software load that allows it to do point-to-point link versus being used as a client device. Now that device, there is a future step in the roadmap where we'll allow a B5 Lite to become a C5 and vice versa, but that's not the case today. Today they are separate products, and if you need to use it as a B5 Lite, you need to purchase the B5 Lite kit to do so. Distance-wise, I recommend out to sort of 5 or 6 miles with that, so sub 10 kilometers. At that level, beyond that, you start to get a little marginal in terms of SNR, and that is going to, of course, drive a lower throughput and a lower level of reliability of that service. Stepping up from that, we have the B5, which is our 4x4 solution, able to deliver 1.5 gigabits per second of aggregate throughput. And so the B5 Lite is a 20 dBi antenna. The B5 is a 25 dBi antenna. So you get a little bit more distance from that. But still there is limitations around EIRP limits in different countries that will drive the decision on where should I be deploying what product. And so the inflection point for us, where I should be considering B5 versus our connectorized platform, is around that sort of 9-10 mile mark. So here we've sort of got marked as sub 15 kilometers. What I say to people is, if you're on that fringe and you're not sure what the performance of a B5 is going to be like, the B5C is usually a better option because you can connect larger dishes. So maybe I want to connect a 32 or a 34 dBi dish, which will get me performance where I can go out to much greater distances. And we've taken a B5C out to 60 miles and beyond, so 100 kilometers. It is something that can support those sort of distances with the large enough dishes, with planning to make sure you've got line of sight and making sure that you've got enough power to do so. So in terms of thinking through the matrix of which of the unlicensed 5 gigahertz backhauls to use, the design tool that we have on our website is a really great starting point, because we will estimate how it'll perform, how rain fade will impact it based on your area, whether you have clear line of sight, are there any Fresnel zone obstructions, things like that. So that's a really good place to start if you want to understand the performance here. And then the final backhaul product, the last backhaul product we launched, the B11, which I'm legally required to call the award-winning B11. We won Product of the Year at the recent WISPs award show. Is a 11 gigahertz licensed product that has fiber on there as well. So that is something where you can connect to the device and use either copper to do PoE and data, or you can use the PoE over copper for an Ethernet and then use fiber for the data connection. So really good for installing if there's FM towers and other things like that that are potential interference with an Ethernet interface, and a range of dish options available for that for licensed use. Another good place to start with that is our design tool. We took the entire 11 gigahertz database here in the US and ingested that and visualized that to allow you to understand where you might be able to license a path within that area. And you can also then use the tool to submit the proposed path of what you would like to do off to coordination, and we can streamline that process for you as well. So really it does, we have a range from very short distance connections with slightly lower throughput up to very high distance connections in both an unlicensed and a licensed model. So there's a real sort of pick your own adventure in terms of what you're trying to achieve and which product we would recommend. So on to the access platform. So two different approaches here is the what we call the suburban and urban model, which is supported by the A5, and what we consider the more traditional rural type market, which we support with the A5C. And I'll go through each of the applications here in terms of when you would choose what. So the one of the considerations is, of course, distance. So at longer distances, it's going to almost invariably drive you towards using the A5C, just given the limited gain that's available in the A5 as a platform versus being able to use external antennas. The other factor is client placement. So the A5 has a 360 degree coverage pattern, meaning it's most suitable where I'm trying to cover clients in all four directions of the compass. With the A5C, if I had a situation where all my clients were to one side or within a segment of where I want to place that access point, then even if I'm doing a shorter distance type service, the A5C still might be a better solution for me, just given it's more efficient using the spectrum by being able to direct it and target it a little bit more by using sector antennas to do so. So back to the rural case in terms of what that looks like, the client devices, which we've covered, connecting to some sort of sector or panel antenna, cabled into the A5, and I'll go through the options available there in a moment. And then from there, it's really about, from the tower location, using backhaul radios, either licensed or unlicensed, to be able to get back to where I've got fiber. And that's really where the hybrid fiber wireless comes into this. You jump off back to fiber where you can get it most cost effectively, which is usually going to be in the data center or some central POP that you have available to you. Now, the panel options, we've worked with KP Performance on getting some 4x4 quad polarization sectors out. So these are 4x4 access points talking to 2x2 clients. So what that means is that if I've got a 65-degree sector, as I have here, I've got the ability to offer 2x2 streams to multiple clients. And that's really the application here. And in addition to that, I can also get some beamforming benefit by doing the quad polarization in the way we do. I can beamform towards those clients, which gives me an extra 3 dB of gain, which also means that I'm isolating those a little bit more from noise. The other application of that, which is from taking a single radio to wanting to do 8 streams in a single direction, is the X8. And in that situation, I'd run 2 A5Cs on separate frequencies and be able to really just double the amount of clients I could support at any one distance. And that is a question that comes up a lot in terms of what's the maximum clients we recommend on either of our access platforms. We say that the technical limit is 100. The practical limit is more like 40 to 50, and that's not a limitation in terms of the performance of the access point from a CPU perspective. that's just a limitation in terms of how we manage and share the airtime. So if you start pushing beyond 50 clients, that means that it doesn't take much for a few of those clients to be doing heavy downloads for them to be stealing more airtime and bringing the performance down for everybody. So the practical limit is 40 to 50, and you should think about that as you do your planning and not really pushing it beyond that too much. Now, the shorter range, the suburban urban version of this is what we call a micropop. And in the micropop environment, we have much shorter distances between the client and the access point. And the reason we do that is that we want to make sure that in these urban environments where the noise floor is typically higher in terms of 5 gigahertz, that by reducing the distance between client and access point, we can get a signal that's strong enough and so far above that noise floor that I can still get the maximum modulation rates and support the max phi rates that are available in 802.11 AC. And so in this environment, one of the bigger challenges that comes up is that as I go do these micropops, because these are designed to be shorter distances rather than being on a tower, you would typically see these installed in buildings in the neighborhood or in people's homes, what we call a hub home, nominating a person's home within that neighborhood as being the central point where the access points in that city block, say, for example, are going to connect back to. And so that is where we have a slightly different solution there in terms of how do I actually get the connectivity or the data back to a central point. 5 gigahertz can be used for that, and we do see a lot of people using a combination of B5s and B5 lights for those shorter hops back. But it really does lend itself a little bit more to things like looking at not 11 gigahertz. It's not a really good for the shorter stuff, but 24 is a good solution that gets used there, and 60 as well. So there's people using a variety of different things because they, in general, would like to keep the 5 gigahertz spectrum clear in those neighborhoods so they can use that for access point planning. Now, the ideal situation is where I have fiber at each of those pop locations and I can terminate that fiber into some sort of switch and then connect it into the A5 over PoE. So that's obviously not always going to be the case in suburban areas, but as you get into denser urban areas, the likelihood of that happening increases. So in terms of theory of operation of the A5 product, it's what we call a quad sector product. So it's not an omni, which we harp on a lot. It is actually much more intelligent than that. And again, this is a 4x4 client 4x4 access point talking to 2x2 clients. And so what happens to the client is that it's getting 2 streams at any one time from 2 of the antenna faces here. So what the result of that is that we're not indiscriminately blasting RF in all directions. We're being much more targeted and only communicating on the antenna elements that are closest and have the strongest signal strength to each of the clients we're communicating with. And so as I build this out in terms of the ultimate deployment scenario for what we're looking for here is these cells is something where we think of these as having a 500 meter radius or less, and that's driving a sort of density of around 400 households per square kilometer. If it's denser than that, then of course you would reduce the distance further. The backhaul, which we've already spoken about, either fiber feeding these pops or using a backhaul technology of your choosing to get the capacity back to where it needs to be. From a client perspective, what we're trying to deliver here is a fire rate of up to 250 megabits per second. So that might not be your model. Maybe you're offering much lower services. Well, we also allow you to rate limit in both the client and the access point. But we do really want to, when we start getting into competitive areas where maybe for $100 a month I can get DOCSIS 3.0 or DOCSIS 3.1 solutions that can achieve those sort of speeds, then I want to be able to compete with that by offering a much better service where the speeds will burst up to those higher levels when needed. But on average, it's something where you want to share the airtime much more fairly rather than having individuals being hogs of the airtime that's available. And then, of course, the crown jewel of all this is the GPS synchronization, which we're working on, where I'm able to synchronize network wide. So our application of GPS does not involve an external GPS receiver. Each of these devices independently talks to a GPS satellite and gets its timing source, and that's synchronized network wide, meaning that I can reuse the same channel at each one of these sites and have the synchronization and apply TDMA to make sure that I'm being very efficient and I'm not getting self-interference between the clients and between the access points. So that's huge in terms of the ability to take the wider channels needed to achieve the sort of speeds we're talking about, which when we say a 250 megabits per second experience down to the client, that requires an 80 megahertz channel to achieve that. So that's really where it all sort of ties in together, and the sort of difference in terms of our approach to getting timing sources does allow us to synchronize the devices with no out-of-band communication between them. So no IEEE 1588 and no need to be physically wired into a common timing source. So the last thing I'll sort of cover here is just around our cloud. So we have now deployed the micropop planner within the cloud, so please get in there and try that. We are working on the A5C planner next, where we will have the ability to come in here and plan different types of sectors. So one of the big questions I get a lot is that people like the idea of what we're doing with, say, the quad polarization sectors from KP, but maybe the client density they have in a given direction doesn't require that much capacity in, say, a 65-degree sector. What we're seeing some customers want to do is split out 2 of the connectors to one sector going in one direction and 2 of the connectors out to one sector going in another direction, where you're running still on that same channel, but maybe I'm using 2 65s instead of 2 dual polarization 65s instead of a single quad polarization 65. So we want to be able to help model that within this tool in terms of understanding the performance limitations and the best way to deploy it into a given area to support the services you're trying to offer. So expect that to come out sometime next month in terms of the A5C planner, but the A5 micropop planner is there now. And there's some really neat things in there around helping, planning around what my sustained and commit rates are and how oversubscribed I'll be at each access point based on the service plans I offer and things like that as well. So that's it in terms of the coverage of our solution. I just want to mention that we do have another webinar coming up. Go to mimosa.co/to-the-point to see both the recordings of previous webinars and be able to register for future ones we have coming up. You will receive an email with a recording of this presentation. You can feel free to email us at sales@mimosa.co if you have any questions, and we can help with any of the planning or any of the product questions you might have to understand how we could potentially fit Mimosa into your network. So that's it from me. Any questions, feel free to type them into the GoToWebinar box there, and I will get to those. Great question. Somebody here asking, is there compatibility with other types of hardware, or is this a rip out and replace? So our access points have the ability to operate in a Wi-Fi compatibility mode. And so what we do have a lot of our customers doing is they're putting an A5 in and then connecting it to the older Ubiquiti clients, so the M series clients. Their AC clients do not allow you to turn their proprietary TDMA mode off, which is their AirMax mode. So there's no compatibility with AirMax. But you can run your network where you have a mix of legacy Ubiquiti clients or Cambium clients operating in a Wi-Fi mode, and be able to mix in Mimosa clients in there as well, also operating in that same Wi-Fi mode. So yeah, absolutely, we have a migration path that allows you to put the access point in today, and then as time suits or as the business need requires it, go out and upgrade the clients to Mimosa clients to enable the TDMA mode in the future. So another good question here, where does the G2 sit in a layer 3 perspective? So one of the things that's unique about our products, let me address that just from a layer perspective with all our products. Our Backhaul products, we made a very deliberate decision to make those purely layer 2 IP bridges. And what I mean by that is we try to keep them as simple as possible from an IP perspective. So with the exception of some management VLANing in our Backhaul products, we don't do a whole lot. We don't do routing, we don't do NATing, we don't do any of those layer 3 and up type functions. Our access points and our client devices, within the access point is expected to do layer 3 and higher functions. So as a result of that, we actually put a network processor in that device, and we do a lot of functions there within that access point to be able to do the typical access point style management that you would expect to see. And that's when I say that we don't expect the client and performance limitations from the CPU power. That is why that is the case, because we do have this gigabit class network processor within there. The client devices themselves, we have those as bridges as well. So they are a layer 2 IP bridge. And in an environment where you're using a G2, the G2 would act as the layer 3 termination point. So you would be doing PPPoE from that device. You would possibly be doing in the future, when we support it, DHCP option 82. There's many different ways that you can use that device as the point that's the demarc from an IP perspective between your customer's network and your access network. Now, the access network itself, we can do client isolation and a lot of the other features there within the AP. but the actual client platform itself does not support routing or NATing within the C5. You would do that in the G2 or within another routing platform of your choosing. So the question here about what are the advantages and disadvantages of deploying A5 versus A5C? Really, it comes down to a combination of the geography and what you're trying to achieve, location of clients, distance. So, straight up here from just the A5 perspective, I can support that in out to multiple kilometers. I could put the A5 in and have a client at 2 kilometers, let's say. But ideally, is that what I want to do? No, we think that product is more suitable for where we've got these 500 meter or less type radiuses, because that means the modulation rate's going to be higher and I'll get that next generation services. As soon as I go beyond that radius, that's when I start thinking about A5Cs. And now A5Cs, and remember when I talk client count, if I say it's 50 clients approximately as the general guideline per access point, with an A5 360, that's 50 clients in that full 360. That's not 50 clients per sector. So if I have an environment where maybe north, south, east, and west, I've got 50 clients I want to hit, well, then I can then go put a A5C and do 90-degree sectors in each direction. So I have an A5C doing north, one doing south, one doing east, one doing west, to still achieve that same that 360-degree coverage, but at a much better client scalability perspective, because each of those access points alone will address those 50 clients in that area. We do get asked questions a lot about other frequencies. I would say you're not likely to see a 900 megahertz or a 2.4/2.5 gigahertz product from us. We talk about other frequencies in terms of the access and in terms of the backhaul. Nothing immediate in terms of things you would see in the next 12 months. So no real plans around anything other than pushing the access platforms in the 5 and continuing to work on that platform to get it to mature and to get it to the point where we're happy with the performance we get out of that. So somebody asking here, so unlike the MikroTik client, you do not have full router board functionality built in. And that's absolutely true. To be able to achieve the line rate we want to achieve and to be able to achieve the value prop we want to achieve with those clients, they just do line rate switching at layer 2. And that's why we use the G2 as an option to be able to do the terminating and then virtualize some of those layer 3 functions that you would typically configure in the client in a legacy model within the access point. It's much more cost effective to invest in compute and RAM in the access point than it is for us to go put processors needed to support some of these services into each of the client devices, where a lot of the time those services just won't get used. Really want to thank you guys for taking your time out today. We are legitimately excited about where the market is and the potential in terms of what we can help enable your businesses to do with our products. And so we're really looking forward to what the rest of this year and into next year holds for us. And you look for us to continue to build out success stories and to come up with different deployment models for you guys to go out and try. So thank you, and talk to you again soon.